Engineering Mechanics Static Lecture 7. This is the last topic of Chapter 2, Static of Particle, which is equilibrium in space 3D. This is the objective. First is to draw a free body diagram, and the second objective is apply equation of equilibrium to solve the 3D problem. Particle in 3D equilibrium have same principle with the case of 2D equilibrium, where the total force or summation of force is equal to 0. In 3D equilibrium, the vector equation have three components, which is I, J, K, or force in the x direction, force in the y direction, and force in the z direction. The total of this force is equal to 0. Or if we can write in a scalar form, which is like this: summation of fx is equal to 0, summation of fy is equal to 0, and summation of fz equal to 0. Keep in mind that this is the scalar form and this is a vector form, or we can call it a Cartesian vector form. These are three scalar equations of equilibrium, or in a short form is E of E. They can be used to solve for up to 3 unknown. So if you still remember, for 2D equilibrium case, there's only 2 unknown. For this case, there are 3 unknown. Let's do some example here. If we have case like this, there is a given that crate with a mass of 100 kg, okay, and geometry is as shown. So find the force in a chords AC, AD, and the stretch of spring. So you need to find the force AD, AC, and AB. So keep in mind here, this system is in equilibrium system. So the total force of all the tension here is equal to 0. All the tension here and the mass here. So for the first step, you need to draw a free body diagram for point A. So the particle is here. Okay. Apply equation of equilibrium at point A to solve for the unknown FB, FC, and FD. And the third one is to evaluate the elongation of the spring, which is S equal to FB over spring constant K. So in this case, the information given is you have the coordinate for D, because the coordinate is given here 2 to 1 here, and then you also given the information of angle between each of the string from the axis. Let's say from axis, the spring C is 120 degree, and then from the axis Z, the spring C is 60 degree. So this is all the information that is given. From the given information, the most suitable method that we can use to solve the problem, we can use this method, the first method, Cartesian vector, where the angle is given. Okay, so if you still remember, we have 3 methods here: Cartesian vector, position vector, and the product. So you can use any of the method which is suitable with the problem. So for this problem, for this particular problem, we use this method. So first you need to do is to draw the free body diagram. sorry. So this is the free body diagram. So imagine this is a particle of A. The point A is a particle and being applied with the force of FB, FC and FD. And then there is a mass here. This is also a force, which is weight, is equal to 981 Newton. After you draw the free body diagram, you need to find the vector force for each of the force in Cartesian vector form. So the first one, let's look at the FB. So FB is on the x-axis. So any force that lies on the axis we consider as equal to 1. So FB is multiplied with 1, so it is FB in the component of x only, which is I. So FB is not lies on any component other than x, so component y and z is equal to 0. Now let's look at FC and FD. How we want to find the Cartesian vector form of FC and FD. If we go to the previous slide, we can see that FC, it's been given the information is angle between the string with the each axis of x, y, z. Whereas for force in the d direction, the information given is a coordinate system. So if you look at from the note here, if it is given the angle between the force and the axis, we can use this method to find the Cartesian vector form. Okay, so if it is given the coordinate system, so you can use the method of position vector to find the vector form of the force. So first you need to find the radius or the length of the truss here, and then multiply with the force, then you will get the Cartesian vector form. So in this case, FC is using the first method. So FC, if you want to change to the vector form, so you need to find each of component for each of the axis. For let's say FC, if you want to find the force in a x-axis direction, so you need to cosine the force FC cos 120. So this is in the x direction, in the y direction, so the same thing, you need to cos the force, and then the z also same. So it is become like this: FC cos 120, FC cos 135 plus FC cos 60 degree. So your vector form will become like this. Okay, 0.5 FC I in the I component, negative 0.707 FC in the J component, plus 0.5 FC in the K component. So so for more detailed calculation, let's look at here. This is for FC, we just discussed just now. So this is how you do the calculation of Cartesian vector. Okay, for x-axis, let's say for x-axis, so if you take out the triangle here, so you the one that you want to find is FCX. So FCX over FC is equal to cos 120 based on this triangle. So FCX is equal to FC cos 120. So substitute into here. Okay. So this is actually fc is equal to fcx plus fcy plus fcz. So if you want to find the fcx, so this is the formula. fcx is equal to fc cosine 120. So the other two is same method, like fcx. So if you want to find the fcy and fcz, so you need to use the cosine 135 and cosine 60 respectively. Okay, so that's for fc. For fd, we go back here. It is given is coordinate system, so we need to use this method, Poisson vector, because in a Poisson vector method, the angle is not available, so we use to calculate the radius of the transverse or any cable here, and then after you get the radius RAB, so find the unit vector, which is vector over the magnitude. This is the unit vector, and multiply with the force, then you will get the Cartesian vector form of the force. Okay, so let's look at the detailed calculation here. So we have two coordinate here, which is the origin coordinate, which is 0, 0, 0, and the coordinate of D, which is -1, 2, and 2. So if you look at here, D is in the position where the X is 1 meter away, and then axis Y is 2 meter, so -1 and 2. Negative because it is in the opposite direction of the positive axis, so this direction of X is negative, so it is -1. So Y is 2 from 0 to 2 in a y-axis, and 2 at the z-axis from 0 to z-axis 2. So the coordinate for D, -1, 2, and 2. So you have two coordinate here. So using these two coordinate, find the ROD. So you need to remember to find the ROD. So you need to use the equation of coordinate from tip to the origin. So if you want to calculate the ROD, so you need to subtract tips to tail. Remember the equation. So each component or each coordinate of D, we need to subtract to the origin. Let's say -1 minus 0, 2 minus 0, 2 minus 0 for I, J, K respectively. So you can like this. So your ROD in a Cartesian vector form will become like this. Okay. So to change it into magnitude, so just square for each of the component and square root, and the sum of the square root become is 3. Okay. So from here you have a vector and you have a magnitude, so you can calculate the unit vector, which is unit vector is equal to vector of R over the magnitude of R. So it's become like this for each component, -1 I plus 2j plus 2k, you divide with the magnitude of ROD, which is 3. Okay, so this is equal to this one. Okay, so this is your unit vector in the form of Cartesian vector, so you can use this to change the force of magnitude become Cartesian form. So just simply multiply the FD with the unit vector, so it's become like this. So your FD will become like this. So you already have the force of FC and FD in a Cartesian vector form, IJK. Okay. For W, there's another one force, which is weight of the crab here. So the force here is a similar case with the force of FB, which is it lies on directly on the axis. But for this one, this is opposite direction from the Z. So when it is on the axis, directly on the axis, so it is only have one component, okay, because the component of X and Y, there is no component here, so it is equal to 0. So the component is only in a Z direction, which is in a Cartesian form, it is denoted as K, so it is only have the value in a K direction. So because it is in the opposite direction of Z, so the direction is negative, so negative 981 K Newton. So after you get all the force in a Cartesian vector form, so sum up all the force here, so it become like this, okay. Just list all the force here, okay, and then all the force here, if you still remember, if the system is in a equilibrium condition, so it is equal to 0. The summation of all the force is equal to 0. And then group all the I component in one equation, which is summation of fx is equal to 0. And then for j, in a component of summation of fy, which is equal to 0. And in the component of k, which is summation of fz, this is also equal to 0. Okay. So you will have three unknown, which is FB, FC, and FD. Okay. So check it. Make sure you have only three unknown. And then you have three equation. If you still remember, if there is same number of unknown and equation, so the equation can be solved. Okay. So if you have two unknown and two equation, the problem is also can be solved. You cannot have more unknown than the equation, like three unknown, two equation. Probably the problem cannot be solved. Okay. Okay, after you have those three equation and three unknowns, so you can solve for FB, FC, and FD. So do it yourself for this to find all the force. Okay. So you already answer all the question here, which asks you to find all the tension or all the force in each of the cable that being applied force. Okay, so and then the question also asks you to find the stretch of the string. So the string is lie on the FB, force at point B, okay, which is equal to 690.7 Newton. So if you still remember the equation for FK for force of spring is equal to elongation of S multiplied with the constant spring K. Okay, so FB equal to KS. So you know the FB, which is 693.7, and you know the constant of spring is given, which is 1,500. So you can find the S, which is equal to 0.462 meter. So the spring is elongate along 0.462 meter.